Today, I'm going to explain transistor as a switch using battery. In this experiment, I am not using regulated power supply. So you can try this experiment in your house using a 9 volts battery. Let me explain the circuit, how to connect. So this is a transistor. Here I have used 2N3904 transistor, NPN transistor, and base emitter and this battery is a input circuit. Collector, LED, resistor and battery is a output circuit. So first you connect the positive terminal of the battery to 1 kilo ohm resistor and from 1 kilo ohm to base of the transistor, and the negative terminal of the battery you connect it to emitter terminal. Similarly, the collector of the transistor connect it to the cathode of the LED, and anode of the LED you connect it on the 1 kilo ohm resistor. Other end of 1 kilo ohm resistor connected to positive terminal of the second battery, and the negative terminal of the battery is also connected to the emitter terminal of the transistor. So this is your actual circuit diagram. Here I have used a 9 volts battery, positive of 9 volts battery to resistor, and base emitter. This is input circuit and this is a output circuit. So all these connections you make it on a breadboard or a tag board. So after doing the connection, two things you need to remember. Well, the first one is if you want to make transistor as a switch, the base emitter junction must be forward bias. See, this is NPN transistor. This is base terminal, emitter terminal, and collector terminal. Base emitter junction must be forward biased, and collector base junction must be reverse biased. What is forward bias? If you connect positive terminal of the battery to P material and a negative terminal of the battery to N material, it acts as a forward bias. If you connect negative terminal of the battery to P-type material and positive to N, then it becomes reverse biased. So this you must follow. Base emitter junction is forward biased and collector base junction is reverse biased. Then only the transistor acts as a switch. So after keeping all these things in mind, you do the connection. Then how to test the transistor acts as a switch? When you remove 9 volts battery from the circuit, LED will become off. When you connect it back again, the LED will be turned on. So remove LED off, connect LED on. Then you can ask me, even though the battery is connected on the output circuit, why the LED is not glowing? So after removing battery, why it is turning off? When I connect battery, why it is turning on? Even though the battery is connected to the LED. The question answer is, to make the transistor as a switch, base emitter junction must be forward bias. We should apply some voltage to the base terminal. So if I apply base voltage to the base terminal, transistor acts as a switch and transistor becomes on, LED becomes on. If I remove the battery, transistor becomes off. When transistor is off, definitely the LED will be off. In this way, you can make the transistor as a switch just by applying the battery voltage to the base terminal. This same experiment you can do with the regulated power supply in your lab, electronics lab. So once you apply some voltage, 2.5 or 5 volts at the base of the transistor, then LED will be turned on. But since if you want to try this experiment in your house, you can use battery to make the transistor on and off. Now I'll show you hardware connection and how the transistor turns on and LED becomes on with hardware experiment. In this circuit, we are making transistor as a switch. This is NPN transistor. The transistor number is 2N3904 transistor. So you should hold the transistor in such way that the flat surface should face towards you, and there is a dome shape that should be away from you. Like that you hold. When you hold like this, the first terminal become emitter, middle one is base, last one is a collector. So you should connect the 3 emitter base collector in 3 different places like this. I connected. Okay, this is emitter, this is base, and this is collector. So according to the circuit diagram, the positive terminal of the battery should be connected to resistor and from resistor to base. So take 1 kilo ohm resistor. This is your base. Connect one end of resistor to base, other end to any one point on the breadboard. So resistor is connected. The resistor second terminal has gone to base. The first terminal should go to positive supply. I will connect this to positive supply. Okay. So this much connection is over. Emitter should be connected to battery negative. The first point is emitter. This is battery negative. Battery negative, I will connect this to emitter. Okay, so this much connection is over. Next, collector should be connected to cathode. So this is your LED. Long lead is anode, short lead is cathode. Cathode should be connected to collector. So other LED terminal you connect anywhere on the breadboard. Anode should go to resistor. So take resistor. One end should go to anode, other end to any one point on the breadboard. So from resistor it should connected to positive terminal of the battery. This is positive terminal of the battery. So connect this here. And the negative terminal of the battery should go to emitter. Emitter is the first point. So when I connect this, the transistor is now acting as a switch. So LED is turned on. LED is turned on. So when I remove the first battery, transistor is turned off. When I connect again, transistor is turned on. When I remove, transistor is turned off. In this way, transistor is acting as a switch.